Let's look at future value of an immediate periodic payment stream. Justin invests $7,500 at the start of each year. If he earns an average annual rate of return of 6% compounded annually, how much will he have accumulated after 22 years? This is a future value of an immediate periodic payment. So it's a little tip for these questions. The payment cannot be equal to 0 since the problem involves periodic cash flows. So there always has to be a value for the payment. The interest rate may need to be adjusted to account for frequency of compounding and the frequency of payments. In this case, it isn't because it's compounded annually and the payments are also annually. And the N must match the frequency of cash flows. So this is yearly. Okay, so let's look at the solution. We'll just show it all. So the mode is beginning since Justin invests at the start of each year, okay? So mode is beginning because he invests at the start of each year. The present value is 0 because he hasn't started saving yet. The interest rate is 6%. And since both compounding and payment frequencies are annual, so there's no adjusting for that. The time period is 22 years. And the yearly payment that he pays, it's a negative because it's leaving his bank account and going to the account, is $7,500. So what is the future value of Justin's account? Let's take a look here. So let's go ahead and clear it. Second function alpha 0, 0. And it's beginning, so we need to second function FB. It's the beginning of end, so there's a begin there, BGN. And let's get going. So 0 present value, 6% interest for 22 years. And the payment is $7,500. So compute the future value. So Justin's savings will grow to $344,969 over 22 years, assuming he invests $7,500 at the beginning of each year and earns an average rate of return of 6% compounded annually.